Hi everyone. So this morning we'll talk a little bit about Active Directory, and more specifically we'll talk about maybe a lesser known topic within Active Directory that are group policy objects, and we'll cover some standard exploitation vectors that we can use to actually exploit group policy objects in Active Directory. And we also cover a new exploitation vector that we released a few months ago following a pen test. A few words about me first. I'm Quentin Roland. I'm a pen tester at Synactive. So we are a French security team, and we are specialized in offensive security. I kind of like Active Directory. I think it's fun, and I'm focusing maybe on lesser known Active Directory attack vectors. So kind of weird stuff like GPOs, organizational units, things like that. Some introduction. So a few months ago, we were performing some internal tests on an Active Directory environment, and we were in an unauthenticated position, and frankly, we did not have much to go on, so the domain was reasonably well hardened. We didn't have any quick wins. But what we were able to do is that we were actually able to perform some NTLM relaying attacks, and we were able to relay a user that had some not much privileges, but it did have a weird permission that's on a GPO that was applied to a domain controller. And so this sentenced down the rabbit hole of GPO ACLs, attack vectors, that we will explore together. But first, why should we even talk about it? Well, GPOs are pretty high-value targets in Active Directory. I mean, if you compromise a GPO, if you exploit a GPO, you can actually compromise all the objects to which the GPO applies. So this can very often lead to some very high impact privilege escalation scenarios within your Active Directory environment. And despite this fact, GPOs did not receive as much attention as some other trendy topics in Active Directory, such as ADCS or something like that. So both from the offensive and the defensive side. So that's why we are going to talk a little bit about it this morning. A quick table of contents. So first, we are going to just explain what group policy objects are, if some people are not familiar with them, and how they are actually implemented in Active Directory. And then we will present the standard attack vectors that we, up until now, just use to attack GPOs. That is direct GPO editing. Then we will present some limitation of this standard attack vector, and we'll precisely demonstrate that this is not applicable in some NTLM relaying scenarios. And then we'll present the alternative approach that we developed and the tool to automate the attack that we also developed and that we called GPODT. So there will be two live demos during this presentation. A first one to present the standard attack vectors to attack GPOs, and the second one to present the working of the alternate attack vector. So hopefully this goes well. No reason. So let's jump into it. First, we'll just provide some context on group policy objects and how they are implemented in Active Directory. This will be important to understand the attacks, plural. So on a very high level, GPOs are simply a collection of settings that you want to apply to your Active Directory objects. So if you want a user to have a certain configuration, if you want a computer to have a certain configuration, you just create a GPO. That can be anything like just local firewall settings. If you want some software installation policies, you want to run some scheduled tasks on your computers regularly, you just define a GPO and you apply it to your objects. And there are two kinds of GPO. So you have computer or user GPO. As the name indicates, computer GPO applies to computer. User GPO applied to user. And they are not directly applied to the objects. They are applied to what we call organizational units, but they are simply some logical Active Directory container that contains users or computers. So you can just manage your GPO via the Microsoft GUI program, the Group Policy Management Console. And they are also applied every 90 minutes in your domain for standard objects, so standard users, standard computers, and every 5 minutes for domain controllers. So a small screenshot of Group Policy Management Console. You can see on the left you have your organizational units, and you have your GPOs that you link to the units. So the objects that are contained within just apply the GPO. Now let's jump a little bit more into the concrete implementation of GPOs. So when you have a GPO in Active Directory, you actually have two components. First, you have what we call the group policy container, and this is an object in the LDAP directory of your AD. And this LDAP object contains some GPO metadata, so the name of the GPO, the description, the version of the GPO. And then you have another thing that we call the group policy template, and this time it's an SMB share that contains the actual files, XML files, typically, that describe what configuration you want to apply to your object. A visual representation of what I just said. You have a group policy object that is characterized by the GUID. Up there, you have the LDAP object, so the GPC, and the FQDN of this object is also characterized by the GUID of the GPO, and it is in the container policies system. And down there, you have the GPT, so the group policy template, the SMB share, and by default, it is on the well-known domain controller share, that's the sysvol share, and it is characterized also by the GUID of the GPO. So that was a quick introduction on GPO. So now that we know how they are implemented, how do we attack them? So let's assume that I have compromised a user that has write permission over a GPO. How do I exploit this to typically compromise all the objects to which the GPO applies? So there is a pretty cool feature in GPOs that is called immediate tasks. And they are basically just arbitrary commands that you can define in the GPO that will be executed by all the objects to which the GPO applies immediately when the GPO is applied by the objects. And they also can be configured to run with elevated privilege. So for instance, the system account of your Windows computer, you can say just run this as root, basically. So some screenshots that show how you can define an immediate task on a GPO the legit way. So through the group policy management console, you just click. This is Windows. And you can define some arbitrary commands here on the right. I just perform a cmd.exe, who am I? And that will be executed by my clients. So this is a pretty cool feature because, well, the attack vector is then just to simply exploit my write permission to alter the GPO, inject a malicious arbitrary immediate task, and just make my clients execute arbitrary commands with elevated privileges. And well, the most direct or straightforward way to do so is to actually simply just directly modify the GPO. And this is the approach that is implemented in some known tools. So for instance, sharp GPO abuse, PyGPO abuse, or a new GPO immediate task by PowerView. And this is pretty straightforward. Let's have kind of a demo. So I have an Active Directory domain here. Let me log in. I have some AD. Yeah, you can see. Great. I have some GPOs linked to my domain controller's organizational units. So you can see here, I have a GPO that is called GPO direct edit. And when I see the permissions on the GPO, you can see that I have a user that is called cbears that has some extended rights on the GPO, and it has write permission on the GPO. So let's assume that I compromise cbears, and I want to compromise the domain controller to which the GPO applies by abusing my write permission on the GPO. Well, let's run PyGPO abuse. So what I want to do is to add a local administrator to my DC, because, well, this is a quick win, right? So I want to add a user that I call direct edit, and I add it to the local administrator group of my DC. First, let's verify that this user does not exist and that I am not lying to you. So you can see, logon failure, this user does not exist on the DC yet. And then let's run our exploit. So you can see here, I provide the credentials of my compromised user. The GPO ID is the GUID of my target GPO. You can see it in LDAP. This is quite straightforward. And the commands, as I just explained. This kind of worked. So now we have altered the GPO to have the immediate malicious task. And now the next time the DC will apply its GPOs, it will be executed and we will have our local administrator that will be created. So we won't sit in silence for 5 minutes to wait for the DC to apply the GPO. I will just trigger it manually with some GPO updates. The GPO update command that does precisely it, so it refreshes the GPOs. Alright, the DC is applying is GPOs. It is executing currently our malicious immediate task and adding our local administrator. It completed successfully. And now we can connect to the $C share, that is the administrative share, as the direct edit user. It works. We are actually root on the domain controller. So that kind of works. Let's go back to the slides. So this attack vector it's quite neat. It only requires one command if you have the correct permissions on your GPO. So it works pretty well. However, it has some limitations. And the main one that we encountered during our pen test is that we could not exploit it via NTLM relaying. And just a reminder, this was our position. We did not fully compromise the user, but we relayed its authentication data to the LDAP service. So this presentation is not really about NTLM relaying. I will assume that you may have some basic knowledge of what NTLM relaying is in theory. Just a quick reminder, NTLM relaying, you just capture or you coerce some NTLM authentication data to you, and you replay it on Active Directory services so that you can interact with these services with the identity of the user that you are relaying. And generally, the LDAP service is pretty a great target because the signing requirements are pretty low, and this is what we are relaying into very often. Let's go back a little bit. What are our existing tools doing when we are directly editing the GPO? Actually, two things. First, they are performing some modification on the group policy container. Remember the LDAP objects of the GPO. So it uses the LDAP protocol because we need to update the version of the GPO to alter it, to inject our malicious task. We also need to modify what we call machine extension names, which are simply a list of UID describing what the GPO is allowed to do. So we are allowing our GPO to execute immediate task. But the tools will also perform some modifications using the SMB protocol because they have to alter the group policy templates that is on the sysvol share of the domain controller, and typically adding the file that says, hey, the GPO executes a malicious immediate task. Visual representation, you can see here we have modifications through LDAP and modification through SMB. That's how we exploit it. But remember, we are actually performing NTLM relaying attacks on the LDAP service. So we can only alter the group policy container, right, with the LDAP protocol, but we will not be able to alter the group policy templates. So we'll not be able to alter the sysvol share of the DC and to add our file. And if you're wondering, we cannot also perform NTLM relaying with the SMB protocol because the signing requirements on the domain controllers is enforced by default. So this will just not work. So this attack vector will not work in NTLM relaying to the LDAP service. And just some illustration. Imagine that we have an account with full permissions on the group policy container that we provided ourselves through NTLM relaying. When we try to use PyGPO abused, like I did during the demonstration, you'll see that you have an error, an access denied error on the SMB protocol, which is expected. So PyGPO abuse actually modified the GPC, but when it tried to modify the GPT, it just failed, and because our users simply do not have the permissions. A fun fact, Active Directory will actually notice when you have a discrepancy between your permission in the LDAP, so on the GPC, and your permission on the sysvol, so for the GPT, and it will just prompt a pop-up saying, hey, something is wrong, please synchronize your permissions. So going back to our pentest, we are still kind of stuck. So we could only alter the GPC via the LDAP protocol. So we began to dig a little bit. Can we do anything with the GPC? Is there any interesting attributes in the group policy container? Well, it turns out that yes, we have an interesting attribute that is called the GPC file syspass attribute. Actually, your GPOs it is not required for you to host your GPO files on the sysvol share of a domain. You can actually just host it anywhere that the GPC file syspass LDAP attribute points to. So you can define an arbitrary SMB share location in the GPC file syspass, and this will be where your group policy template file will be located. It doesn't even have to be on a domain machine. As long as the clients have network access to this SMB server, you can totally host your file there. And this is not a bug, right? Microsoft said that this is a legitimate intended feature. Also, it kind of immediately crashed the group policy management console, so it is expected, but not as much as you would think. So a little bit of an illustration. Here on the left, you can see the GPC file syspath attribute pointing to the group policy template location. This is the default one to the sysvol shell, right? So everything goes well with the GUID of the GPO, as I described earlier. And I just modified it to input an arbitrary IP address that points to my server. And I just run an SMB server that prints incoming clients on there. And you can see that when clients actually attempt to apply the GPO for which I modify the GPC file syspath attribute, they are coming to me and they are trying to authenticate to me and to fetch their GPT files. So this demonstrates that we can host them actually anywhere as long as the GPC file syspath attribute points to my server. So maybe you can see where I'm going with this. We now have an attack primitive that will work only by modifying the GPC via the LDAP protocol, because what we can do is just poison the GPC file syspath attributes of the GPC LDAP object and point it to my SMB server. And then on my SMB server, I will just host a malicious group policy template with a malicious immediate task. The clients will happily authenticate to me, fetch the files, execute my immediate task with elevated privilege, and they will be compromised. This is the visual representation of what I just said. So first, we are performing some NTLM interception. So we are coercing or just fetching some NTLM authentication data. 2, we relay it to the LDAP service. 3, we use that to modify the GPC file syspath attribute of our target GPO. 4, we host a malicious GPT on our machine. And 5, the clients will fetch the GPT, apply our malicious immediate task. So we actually implemented a tool that will automate various steps of the attack I just described. And the attack is not that complex in theory, but the main implementation challenge was actually to simulate a working SMB server that will serve GPT files, because clients will come to us and will need to deliver the files. And this is not as easy as it might seem, because we cannot just implement an SMB server that doesn't require authentication. Any recent Microsoft or Windows SMB client will just refuse to connect to such servers. And we also cannot just accept any username password and say, here's your files. Why? It is a bit technical, but since 2012, Windows will actually the clients will require you to sign at least one packet with a key derived from the user password. So we have to actually simulate an SMB server that is properly authenticating the users that are coming to us. And for that, we have actually 3 solutions that can be implemented in various situations with various prerequisites. And we'll go over them in the next slides. The first solution is probably the most convenient one, because it is implemented directly in GPODT. So GPODT is actually implementing an embedded SMB server that will perform some netlogon exchanges with the domain controller. So just a reminder, netlogon is the authentication protocol that is used, for instance, by legitimate servers or services on the domain to authenticate incoming clients. So a client comes to you with some authentication data, and the server will ask the DC with the netlogon protocol, hey, can you verify this authentication data for me? The DC will verify it and return to you some signing key, for instance. So GPODT performs this, and it just serves the files to the clients. Prerequisites, 2 prerequisites. First, we should be handling a computer GPU. I'll come back to it in an instant. And we should have a machine account, because netlogon is only available to machine accounts in an Active Directory domain. Let's perform a quick demo. So this demo will be a little bit, we'll actually just retrace what we did during our pen test, actually. So let's perform some NTLM relaying. This was the first step. So I'm just launching my NTLM Relay X instance that I will use to perform the attack. I will simulate the fact that we intercepted some authentication data from cPairs. So in real life, you would poison some name resolution protocol anyway. I just use curl here to simulate it. You can see that I'm controlling the connection. I'm relaying it. It should work anytime now. Great. All right. So you can see that the relaying attack worked. So I'm actually opening an LDAP shell on the LDAP service as a CBELS user because I relayed the NTLM authentication data to the domain controller. So now I can just I have a shell. So here I am actually talking with the DC in LDAP as the CBELS user. What I will do, well, let's see some commands here. What I will do, I will add a computer first. This is a default Active Directory configuration. You can add up to 10 machine accounts as any authenticated user. I will need it to perform some net logon, as I just said. All right, it worked. I added the machine account that is called GPODT. Next, I will actually grant the GPODT account all rights over the target GPO that I am targeting. So here I am targeting again a GPO that is applied to a DC, just similarly to what I did before. All right, it worked, great. So now I have the GPODT account has all rights over the GPC, the group policy container. And at this point, our exploits would fail with standard tools, as I just described, with PyGPO abuse and so on. But we can actually run the GPODT tool. So let's do this. Well, let me just... All right. So GPODT will take the target GPO GUID, as always. The username and the password of the user that has rights over the GPC that we granted ourselves via NTLM relaying. Then the command. Now we will add a local admin called location spoof, for instance, and add it to the local administrator group of the DC to compromise it. And it takes a rogue SMB server IP. So this is the SMB server to which the clients will on which the client will ask for the GPT files that contains the malicious task. So this is myself, because I am providing the SMB server. First, before running it, let's verify that my user does not exist and I'm not lying to you. So nt-logon failure, this user does not exist. Now let's run GPODT. All right. Great, sorry. Let's run it. So you can see that GPODT generated a malicious group policy template with a malicious immediate task, and it is currently hosting it on the embedded SMB server. And it also spoofed the GPC to myself. And now we just wait, right? We just wait for the domain controller to apply the GPO. It will come to me. It will fetch the files, and it will execute my task. Let's trigger it, as always, with some GP update to not wait. All right. It's applying it, and you can see a few things here. So we are receiving an authentication request. The DC tries to authenticate to us to fetch the files. We authenticate the DC via the netlogon protocol, and then we are talking with the DC, and it fetches the gpt.ini file, which is a GPT file. So it seems to have worked. Now we just cancel this. GPODT will perform some cleaning actions, so it will not break your domain. It will restore the GPC 56 attributes. And now we can verify that our command was executed. So it worked. We are root on the domain control. So this worked pretty well. Thanks. So this is working. So as prerequisites, the prerequisites are pretty low, aside from the permissions on the GPO, because you only have to have a machine account, which is something that you can create oftentimes, or you can use an existing one. However, this attack vector that I just explained here only works for computer GPO. It is not actually working with user GPOs, so GPOs that are applying to user objects. For a reason that is still unknown to this day, the netlogon authentication of the incoming clients for the user GPOs is currently not working. And I've spent a lot of time on it, but couldn't fix it. So it's currently not working for user GPO, but we can actually trick a little bit in order to exploit user GPOs. What we can do is that also it necessitates a machine account. Sometimes you don't have a machine account. If you are handling a user GPO or you do not have a machine account, we can, as I said, just trick a little bit and simply let Windows do the work for us and use a writable domain SMB share to host our files. So the only prerequisite for this approach is write permission on any SMB share on the domain. which can be achieved. And in this case, the exploitation scenario is a little bit different. So the beginning is the same. We just intercept NTLM data. We relay to the LDAP service. We modify the GPC file syspass attribute. But this time we pointed to the server that hosts the writable SMB share. And then our clients we upload the malicious GPT to the writable SMB share. And then our clients will fetch it from there and apply it. So this is also exploitable with GPODT. Let's imagine that we have a user GPO with the following GUID that is applied to a privileged user. So for instance, ADM Roland. And we have a user, we have low priv user, and we granted, as always, this user some control over the GPC, the group policy container via LTL relaying. And now there is also a share on the domain that is writable for any user, for instance, a share code public on any server in the domain. So we have write access to it as the low priv user. Well, we can simply launch GPODT with the SMB mode none flag and just provide the path to the writable share. As you can see here, we are just performing a command who am I into the cpoc.txt file. And we provide the writable share, the IP of the server that hosts the writable share and the path to the writable share here. As always, GPODT will generate for you the malicious group policy template, and then it will spoof the GPC file syspass to your server, to your target server that hosts the writable SMB share. And then, because we are not running the embedded server, we are just waiting. You just have then to upload the generated malicious GPT to your server, to your writable share, and just wait for the user to apply its group policy objects. And then it will actually execute the commands, and you can see you will be able to see your outputs in the cpoc.txt file. So this also works pretty well. And the last case, let's imagine that we are actually handling a user GPO, but we do not have any writable SMB share in the domain. Is this actually game over for us? Well, not really. And we can this time actually abuse the Kerberos protocol for authentication. So let me explain. We can actually set up a fake domain controller that will not be on the network of our targets, that will not be on the domain of our targets. This will just be a virtual machine on our host, for instance. And we will simply just forward all SMB traffic to this machine that will act as our SMB server. To do so, there is some gotchas. First, you should then create your fake DC on your machine and just extract its password. Then you will create a machine account, for instance GPODT here, on your target domain. It should have exactly the same password as your fake DC. Then you can create a DNS record. Again, this is standard in Active Directory. All authenticated user can create non-existing DNS records. So create a DNS record, gpodt.com that points to you, to your attacker machine. And then you can spoof the GPC file syspass on your target GPO and just say that it is gpodt.com. What will happen then? When clients will actually attempt to fetch the GPT, this time they will see an FQDN, a DNS name, so they will use the Kerberos protocol to authenticate to the SMB server. And more specifically, they will ask for a service ticket for the host SPN of gpodt.com. What will happen is that we will forward all this traffic to our fake DC, and the fake DC will be able to decrypt this service ticket because it has exactly the same password as the GPODT machine account for which we created the DNS record. So it will actually just authenticate clients and talk with the clients of the target domains as if it was a server on the domain, but it is actually just a VM on a local network of our host, for instance. So this is quite a neat trick. The prerequisites, again, are quite low. You can have simply a machine account and the ability to add non-existing DNS records, standard for any authenticated domain user. And this is quite handy, also handy because it works in hardened environments if you do not have NTLM authentication, because we are using Kerberos. So the attack flow is a little bit more complex here. But first, you add your machine account with a password that is synchronized with your fake domain controller down there. You add the DNS record. Then you have the same step as always. Intercept NTLM authentication, relay to LDAP, modify the GPC file syspass, this time to the DNS record you created. And then for the clients will actually attempt to To reach gpodt.corp.com, we'll forward every traffic received on SMB to our FACDC. It will authenticate client, and it will fetch the files, and the malicious task will be executed. Again, you can do this with GPODT. You just provide the flag that is called SMB mode forwarded. Then you provide same arguments as always, GPO GUID, the commands, here just a whoami into CPOC forwarded, the GPO type. Then you will provide as a ROX SMB server IP, this time an FQDN, so gpodt.corp.com, because this is the value we want in the GPC file syspass attribute. And then you say that this is forwarded, and you indicate here last the IP address of your FACDC. You can see that it is not even on the same subnet, right, than our target domain. It's just really a VM on our host. And then you just upload your malicious GPT. When you execute GPODT, it will generate it to you. You upload it to your FACDC, and you just wait. And you can see here that the user will update its GPOs, and the command will be executed. GPODT will tell you, you can see here on the bottom, that it is forwarding some traffic, so it is also an indicator that it worked for a client. Well, in conclusion, just be very careful about the permissions applied to some weird, maybe not so known Active Directory objects such as GPOs, because you can exploit it not only when you compromise the user that has privileges over the GPO, but you can actually exploit it by just simple NTLM relaying, which means just some name poisoning in your domain, and this can have some high impact. This can result in high impact privilege escalation scenarios. And more generally, we also observed during this research that it was possible to simulate some domain join services, such as an SMB server, by abusing the network authentication protocols of Microsoft, so NetLogon, and we also saw that it was possible via Kerberos, and it can be pretty handy for other attack primitives. It can be useful. And yeah, more generally, that I believe that there are still some fun to have with Active Directory. I believe that the research on Active Directory is not over. There will still be some ACL-based attack vectors that are out there that are unknown and that we can still discover. Thank you.
Thank you, Quentin. Great talk. We have plenty of time for questions in the room. Who would like to start? Just near you here.
Thanks for the talk. I was wondering if you explored using WebDAV as a SMB share for the malicious template. WebDAV to provide the GPT files, do you mean? Yes. Well, GPT files are served simply via SMB, so we do not actually need WebDAV to do so. It is simple, some vanilla SMB exchanges. But you provided UNC paths in the attribute. Mm-hmm. There are mechanisms in Windows which will try it on SMB and WebDAV. Did you try to confuse and see if he would connect to WebDAV, or would client setting on the DC prevent WebDAV working?
This was not the objective, but I can see where you're going. This would be more of a coercing mechanism then, to just lead some clients to perform some authentication with HTTP, so using the WebDAV protocol. This would be interesting to check. I did not check, but would be interesting because indeed what I just described is also a coercing mechanism, right? Because you are effectively forcing clients to authenticate to you, and you can then relay stuff. But yeah, that would be interesting. Yeah, thanks.
No need to hurry up. The lunch is still not ready. We have plenty of time. Another question. Here, Jean-François, if you can bring them up.
Thanks for the presentation. When you get initial access to your user, do you need a specific amount of permission to list initially the GPOs? No,
this is the beautiful part of Active Directory, that you just need an authenticated access to LDAP to fetch all the data of the LDAP directory. So in my scenario, for instance, we are unauthenticated. We relayed the user to the LDAP service. We can actually use this relaying not just to provide ourselves with the permissions on the GPO, but first to enumerate all the permissions of your user that you are relaying on all the objects of Active Directory. You can see then that you have permissions over the GPO, and then you can do your stuff. But you do not need any specific permissions to list GPOs. Just as any Active Directory object, you can just dump everything with your standard user. Yeah.
Okay, thanks.
No problem.
Anybody else? No, don't be shy. The lunch is still not ready. Yes, please. Can you take just a mic, please, so people can hear you?
How much time did it take you to develop the tool, and how many lines are there in the tool?
Well, the tool was not really long to develop because, well, actually it was. I lied. It was because, as I said, the implementation challenge was to actually implement an SMB server that performed some netlogon and that could talk as a legitimate SMB server. That was not that trivial to do, actually. So I would say develop the tool took us around 2 months, for instance, to do. But during our pen test, we had a working proof of concept that was quick and dirty, right? We just took time afterwards to develop the tool to have a working tool that worked more beautifully.
So again, from the blue team side, what would the IDS need to check for here? So you said that what you're using here is something which is used in Windows for some other reasons. I don't know which one. But so what would an IDS need to look for? Like what access patterns he would need to check?
Well, this is pretty easy. So for the attack itself, we are actually altering the GPC file syspass attributes. There is absolutely no reason that anyone should touch this attribute ever. Like, it should always, the GPOs are just always on the sysvulture of the DC. The fact that we are pointing the GPC file syspass elsewhere is just very strange. I mean, I did not encounter anyone that does this in a legitimate way. So you have a pretty clear indicator. And even before that, I would just recommend to enforce LDAP signing, right? To just prevent the NTLM relaying primitive altogether first on your domain controller. This would actually fix most of what I explained here.
Yeah, I have 2 questions for you. I'm not as technical, so I follow, like, trying to not to get lost. There's 2 things that stuck at me. The number one is, even in the third method to simulate the server of policies, whatever, you said, oh, this also, it's manipulating Kerberos, so it also works if NTLM is forbidden. But if I remember at the beginning, you needed to use NTLM, if I'm not wrong. This was one question. And the other question is, it seems odd to me that in that metadata thing, you can change it and point the data to somewhere else. That seems really odd. This is the Active Directory, is the Sancta Sanctorum of the Windows system. Why is that? What did Microsoft tell you? So 2 questions. I don't know if they're good questions, really.
They are good questions. Thanks. The first one is pretty accurate. So indeed, if you have NTLM disabled, you will not obviously be able to perform some NTLM relaying, right? But, well, I should think about it, see if there are some Kerberos relaying possibilities to achieve the same results with full Kerberos. I should think a little bit about it, but maybe this attack is still possible with relaying other protocols than NTLM, and then it will be possible. And regarding your second question, I agree with you. It's really strange, right? Microsoft, again, as I said during the presentation, for Microsoft, this is an intended feature. For a very unknown reason, you can actually point the location of your GPO anywhere you want, not even on domain joined machines. And as I said, the group policy management console just immediately crashes when you attempt to point it anywhere else than the sysvulture. So this is intended, but on the other hand, it is not so. I agree with you. It's strange, but it's there. So thanks, Microsoft, I guess.
There's a question behind you.
So my question is it very common to have like random users that have the ability to write GPOs? Like why did they want that? And also how do you detect it? How do you audit, is there a way to audit your Active Directory for this kind of weird configurations?
Yeah, good question. So is it common to have standard random users have privileges on GPOs? Not really. This was kind of an edge case, but what we can see very often is maybe more some T1 or T2 users that are configured to be able to manage GPOs because, well, they are not T0, right? But they are quite privileged, sorry. And then you can exploit this to go from T2 or T1 user to T0, for instance. This is something that you may see pretty often, actually. So it's still, well, our case was a bit special because we had some non-privileged user that has this weird permission, but it is still applicable in more standard Active Directory environments, I think. What was the second question? Sorry.
How do you detect it? How do you audit for that?
Well, this was an internal audit. There was no stealth involved, so we just ran the Bloodhound tool. I don't know if you're familiar with it, but we just ran some Bloodhounds, and it has some edges with write permission or read permission or GP link permission on the GPOs, and you can just see what user has interesting permissions from your Bloodhound graph. Yeah.
Okay, I see. Thank you.
All right. Thank you again, Quentin.
Thanks.
Please stay a while.